When you stop to think about it, water is used for so many purposes. It's such a common natural resource that we often don't even notice when we're using it. And we certainly don't think much about what happens to it when we're finished with it. But clean water is a resource that we couldn't live without. The reality is that although there is an abundance of water, the supply is not infinite. So when water is taken out of the Missouri River and treated so that Kansas Cityans can have clean water, that same water eventually goes back into the river and is used again by the people in communities downstream. In other words, we all play a role in protecting our finite supply of clean water. And responsibility for clean, safe water does not stop at the state line or the city limits. The way we treat wastewater affects water quality in general. We're responsible for making sure we don't pass additional pollutants onto our neighbors downstream. This responsibility lies primarily with the Kansas City, Missouri Water Services Department. Sample collection, treatment, testing, and monitoring of wastewater requires the services of several divisions. The task of operating and maintaining facilities for the handling of wastewater is a formidable one. Wastewater treatment is a very high-tech business, one that is conducted with the safety and health of Kansas City residents as the top priority. As you'll see in the next few minutes, technology plays a big role in wastewater treatment, as does environmental safety, fiscal responsibility, and the appropriate blending of the old and new. Kansas City's sewer system development began over 140 years ago when the first sewers were built. Kansas City was a thriving river town, but its continued progress and growth required adequate sewers. As a result, construction began on the Main Street sewer in 1855 and was completed in 1871. It normally wouldn't have taken 16 years to build the stone and brick sewer, but the Civil War caused a 6-year delay in construction. As the city grew, so did the demand on the Main Street sewer. More sewer lines were built, and as technology grew more complex, Kansas City's wastewater treatment program advanced. Today, there are thousands of miles of sewer lines traveling below our dynamic, bustling city streets, commercial businesses, and homes. The first step in wastewater treatment is collection. Wastewater from homes, businesses, and industries travels through the sewer lines to large trunk sewers and more than 47 wastewater and stormwater pump stations located throughout the city. In the past, workers would have to actually go down into the sewer lines to inspect and repair them. This can be a very dangerous job. But today, the industry has reduced the amount of time workers spend inside the sewers due to advancements in technology. The vast majority of the lines can be inspected with video cameras that travel throughout the entire sewer network. The videotapes can then be reviewed by city personnel and repairs made when necessary. This technology is especially important for older sewer lines, since some of Kansas City's sewers are more than 130 years old. If a sewer line collapses, the street above it will usually fall too. In addition, broken pipes can cause wastewater to back up into basements. This type of hazard can usually be avoided through frequent video monitoring and ongoing maintenance and repair. The Sewer Maintenance Division completes more than 700 repairs, checks for environmental compliance, and cleans hundreds of miles of sewer lines each year. Kansas City has two types of sewer systems. In older areas, wastewater and stormwater share the same pipe. This is called a combined sewer system. In a combined system, all flow, wastewater, and stormwater is transported to diversion structures. When the weather is dry, all flow then goes to a wastewater treatment plant. During wet weather, as much flow as possible is transported to the treatment plant, and the excess is diverted to a receiving body of water. In newer areas of the city, wastewater and stormwater are transported in separate lines. This is called a separated sewer system. In a separated system, wastewater is transported to a treatment plant, and stormwater is discharged into a receiving body of water. There are 3 large treatment plants in Kansas City and 5 smaller plants. The 3 large plants discharge to the Missouri River, while the smaller plants discharge to streams and creeks. The Blue River Treatment Plant is the largest in Kansas City. Blue River typically treats 80 million gallons of wastewater each day, Other treatment plants around the city collectively treat about 30 million gallons each day. When wastewater arrives at Blue River, it first passes through a channel called a partial flume for flow measurement. Then it flows to a screening building that's made up of a series of various sized screens. These screens trap paper, rags, cans, and other trash and debris as the water passes through them. The coarse screens are hand cleaned, and the fine screens are mechanically cleaned. Items captured during this preliminary treatment are removed and transported to a landfill for disposal. Many of these items are washed down the sewers by rainstorms. Littering is irresponsible and causes pollution in our streets. This litter will also end up in the sewers. Flushing items down the toilet or littering the streets doesn't make that trash just magically disappear. It still has to be dealt with at the wastewater treatment facility. Too much solid waste from this type of trash can cause overflow points to overflow sooner than necessary during heavy rainstorms. Following the screening process, the wastewater is pumped to what are called aerated grit basins. Here, the water flows slowly so that sand and grit can settle to the bottom and be removed for disposal. The water will then arrive at one of 4 primary basins. Each basin holds 1.5 million gallons of water. The wastewater stays there for about 2 hours. Grease and oil are collected by skimming it off the top of the water. The solids which sink to the bottom are called sludge and will be collected and pumped for further treatment. At this point, the water becomes visibly clearer. Wastewater treatment splits at this point in the process. Sludge collected from the bottom of the primary basins is moved to a holding tank. Moisture is removed from the sludge to form a cake. The cake will be sent to incinerators where, at temperatures reaching as high as 1500 degrees Fahrenheit, it will be reduced to ash. The incinerators are equipped with air scrubbers to meet air pollution standards. The ash from the incinerators is mixed with water to form a slurry and pumped for storage to an ash lagoon. Secondary sludge from treatment plants first must enter a thickening stage. The organic materials in the sludge will stick to air bubbles and float to the surface. It is then collected and pumped to an anaerobic digester. Here, tiny organisms eat the nutrients in the incoming sludge. This process decreases the sludge volume and produces methane gas. The methane gas is then used to fuel boilers and engine generators at the Blue River plant. Reusable solids, now called biosolids from the anaerobic digesters, are pumped to the Birmingham farms. The residuals management section will reuse these biosolids for fertilizer and soil conditioning of croplands. Overall, about 21,000 dry tons of solids are generated each year by Kansas City's wastewater treatment facilities. This material is either incinerated or converted to fertilizer. Either way, the Water Services Department disposes of the material in an environmentally safe and cost-effective manner. The Water Services Department is also cooperating in the disposal of yard waste. The yard waste is ground and spread onto city-owned land along with wastewater biosolids as a fertilizer and soil conditioner. Now, returning to the treatment of wastewater, the partially cleaned water in the primary basins moves on to a secondary stage for further treatment before being discharged back to the river. This phase begins at the secondary treatment plant, where the water is pumped to the top of 40-foot biotowers called trickling filters. The water is sprayed over honeycomb-like material. As the water trickles down through the filter layers, bacteria grow and reproduce, eating the nutrients in the water. The other 2 large treatment plants use an activated sludge process instead of the trickling filter. Activated sludge is a mixture produced in wastewater which uses organisms to speed up the decomposition of waste. Eventually, the activated sludge is allowed to settle out. Secondary settling basins follow the trickling filters or activated sludge treatment. Any secondary sludge from these basins is pumped back to the sludge thickeners to be digested and reused as fertilizer on cropland. Now, the water that remains has gone through all the required treatment processes and is ready to go back into the river. The Wastewater Treatment Division complies with a National Pollutant Discharge Elimination System permit to ensure that the water returning to the river will not harm aquatic life or the people living downstream from Kansas City. There are a variety of other precautions that the Water Services Department takes when treating wastewater. For example, the Water Quality Control Laboratory conducts more than 6,000 tests on wastewater each month. Laboratory personnel are experts in their field, and they work with state-of-the-art equipment. The laboratory is capable of analyzing more than 500 different compounds in water and wastewater and performs over 25,000 total tests each month. Many of these tests are for compounds not yet regulated. This allows identification of substances that may be of future concern to health or the environment. Pollution prevention is another precautionary step in wastewater treatment. The Industrial Wastewater Pretreatment Program is administered by the Industrial Waste Control Division. This program enforces federal, state, and local limits on substances going into the sewer system. The city's pretreatment program was established long before the Environmental Protection Agency was formed in 1972. These standards are designed to help protect citizens, treatment plants, sewer lines, pump stations, and water services employees. Acid, grease, and heavy metals are examples of the substances that are monitored. Pollution prevention through industrial wastewater pretreatment is another example of how the Kansas City Wastewater Program meets and exceeds federal and state mandates for clean water and environmental responsibility. It is essential to maintain the functional and technological reliability of the equipment and facilities that handle the wastewater. This is accomplished by a long-term program for capital improvements. Engineering Services is employed to plan and carry out this program to make major repairs and equipment upgrades, improve efficiency through technology, and provide expansion for community growth. Engineering Services conducts such projects on the city's treatment plants, sewage pumping stations, and flood control stations. The employees of all divisions of the Water Services Department, which process wastewater, are committed to the safe and efficient operation of their facilities. Their primary goal is to return this valuable natural resource to our rivers and streams in a clean, safe condition at the lowest cost to our customers. Ultimately, the water arrives back at the Missouri River and flows downstream to the next community. Because of the conscientious efforts of the Water Services Department employees, we can be confident that we have returned this natural resource to our rivers and streams in a condition that is often better than when we removed it. The aquatic life and our neighbors will be safe, and the recycling of nature's amazing resource can begin again.